So Fletcher's going to talk about Test Kitchen. So over to you, Fletcher.
Awesome. All right. I'm going to get some notes out because I thought before we start that I'm kind of speaking for myself as a Canadian. I'm from Edmonton, so I'm really stoked to be here for the first Canadian DevOps Days. So I'd like to thank the organizers, the sponsors, the volunteers for kind of making this happen. I pledged that I'd try and make it wherever that was going to be in Canada, and it's awesome. It's Vancouver. So how about we just say thank you to everybody. And additionally, I'd like to give a special shout out to the live stream. This is the first time I've attended a DevOps Days, although only in person. So I have been to other DevOps Days before, just from lurking on the live stream. So if that's going and there's people there, hi live stream, and in the balcony too, because I don't think we're getting enough shout outs up there. So, and lastly, I was warned that the screen was going to be really large, and so I really was surprised at how big it was. So if you'll indulge me, I just was kind of curious to see what these might. That's pretty awesome. That's pretty awesome. This one is nice. It's like, what's he gonna do? Yeah. All right. Okay. So get that out of the way. So really, what I want to talk to you about is a tool called Test Kitchen, but really fundamentally for me, what this is about is confidence. So for me, I suspect for a lot of other people, pushing your code or your infrastructure into production sometimes is probably feeling like that. And you might not even really know what the water's like or if there is water there. Sometimes it's your choice to kind of make the dive, and other times you have your business is helping you to, I don't want to say push, but you never know. So. This is, again, Test Kitchen. So I'll just put up a whole bunch of words here, and we'll hopefully get this unpackaged, and it'll make a little bit more sense as we go. So Test Kitchen, it's a test harness. So you could think of it sort of if you were a web developer, kind of your Selenium suite or your Cucumber suite for infrastructure code. And it's to help you execute your configuration code, whatever that happens to be, on one or more platforms in isolation. So there's kind of a lot going on there. Let's just try to break that down a little bit. We'll do that in a bit. Currently, it's working with Chef. That's because that was the configuration management tool that I was using. That was the sort of pain that I was in. I wanted to work on Chef cookbooks. You could sort of think of those as sort of the unit of software library in the Chef realm, a Puppet module, Ansible playbook, things like that. So, but it became pretty clear after working on it for a bit is that the part that's actually doing Chef isn't really that big in a way that we could probably substitute a couple other tools in here. And it's more the pattern in what Test Kitchen helps you do, which is really to execute some code on a platform for real. So this was this particular incarnation of Test Kitchen. I started. It was rather by accident. It was in December. It was a Friday night. I was doing some open source work and taking pull requests and trying to verify them, and doing what I'm sure lots of people do, which is running the code and using Vagrant or some VMs and kind of poking around and making sure like that looks good. That looks good. That's totally broken. What was I doing there? It was originally designed as just basically a way to like automate Vagrant runs, like lots of them, so that I could fire it and wait 3 hours to do all the different tests and go to sleep and wake up and hopefully everything's good. So it was, I think, into early January that I got up the courage to approach OpsCode because they had a tool already. It was called Test Kitchen, which did a very similar thing. I didn't really intend on making a tool that was very similar to their tool. And the response was really good. We decided that we should combine efforts. So that's how I managed to get a commit bit into an ops code repo despite not being an ops code employee. So I have to thank them for having the courage to take on a crazy outside community person and sort of appropriate a tool that was theirs. So again, this was kind of born out of frustration, and frustration doesn't make me happy and causes me angst, and it doesn't make me really want to work on stuff. And at the time, this was open source code that I was working on, so it's just my own time, my own, I'm not being paid for it. So really what I want to be is I want to be happy. And I found that, that this tool was just enough to let the development process get me back to something resembling like a test-driven approach, like with a feedback loop, speaking with my kind of developer cap on, and it made me happy. I found that, that thankfully I wasn't alone as I talked to other people in the community and had them try it, and people would start to play with it. People have had success, and I'm hoping that it's making other people happy too. So if there's one thing to take away, I hope I can make more people happy. So for Test Kitchen, these goals are a little bit reverse engineered because I didn't really go out and decide, I'm going to make a tool today. I want to solve a problem, and oh, that kind of worked. So simple, because it started off pretty simple. Hopefully about the most simple workflow that you need to get the job done. I didn't intend on this being a big prescriptive, like you need to do your flow like this. I just want like a command that you can sort of run as you're writing your infrastructure code. I want it to be as fast as possible because really, and especially when I'm off the clock for employment, my time's pretty valuable to me, so I don't want to be waiting around for, in this case, it was basically compiling Ruby. It was automating the RVM cookbook, so it was compiling Ruby across all these platforms, and like to do a run on Ubuntu would be like 45 minutes, and then on an older version of Ubuntu it was like 48 minutes, and then on CentOS was like 40 minutes. So I'm waiting for like 3 hours just to make sure I didn't break anything. And so it's supposed to be fast, but I also wanted to make sure that whatever you happen to be writing right now, whatever dependencies that you're pulling in that might be new, that has to be fresh in the environment when you're running it. So the freshness of your code and the configuration you want at that moment should trump any speed thing, but we can make other parts faster, and this doesn't end up being a huge issue. So I was hoping to make something rather declarative to sort of express your testing problem, and in that sense, more of a static description. I took a lot of inspiration from the Travis CI project. They have basically it's a YAML file description of, I have a Ruby project and I want to test against these Rubies, and I have a gem file, but it's over there, and the test command I want to run is who knows what. So it was just enough declarative configuration so that the platform understood what to do. So I was trying to see how far could we sort of push that. Because while I might want to use this tool in development on a workstation, it would be great if the same tool could be used on a CI system. So it has to be pretty dumb and pretty easy to wire something like that in. And hopefully this text might be a little small. This is kind of what I was hoping would be sort of a bare minimum. So this is assuming right now like a chef cookbook kind of a Ruby project. If you happen to have a gem file in there, maybe you need to do a bundle install to get some dependencies. Maybe that pulls in Test Kitchen. And then rate command, a Thor command, just like one thing that you need to run, and it'll just happen. And if there's any failure, don't exit 0. Just exit anything non-zero, that's a failure. And if you have 0 exit, then it's clean. I was hoping to kind of divorce the testing frameworks and the approach of sort of how you would verify that code that ran. I didn't want to necessarily pick any winners or bundle in any large dependencies that might change over time. So this was my way of kind of punting on some of these decisions. So in that sense, it kind of accidentally by design ended up being somewhat agnostic for how you do your tests. It sort of happens after your configuration management code has run. And because I want to be fast, wouldn't it be great if, in some situations, if you could actually run them in parallel? Wouldn't it be great if you could actually run it in parallel? If you could run it in parallel, on your workstation, you don't necessarily, you can't necessarily make sense of the logs that are streaming in, totally crazy order. So there was a requirement, and I spent an inordinate amount of time to make sure that every single test case has its own dedicated log file for forensics, and to figure out if you really only care about this one stream but you want to run the others, you can sort of focus on there. And also, I was hoping, the project started with Vagrant as sort of the back end on my workstation, but I knew that some shops use Amazon EC2. There are some businesses that are standing up their own OpenStack. There's other companies that have their own private cloud. It'd be really nice if there was a lightweight way for them to plug in their own virtualization, cloud, bare metal, whatever, backend, so that you can test in an environment that's appropriate to you. Again, don't really want to pick winners if at all possible. So we have sort of the simplest plugin system that we could get away with to sort of make that happen. Test Kitchen itself is a Ruby gem. So gems are sort of the packaging distribution for Test Kitchen, and that's the same thing for these drivers. They're the thing that allows Test Kitchen to run stuff on EC2 or on Vagrant or Docker containers or Rackspace, stuff like that. This was a little bit in reaction to sort of the first generation of the Test Kitchen tool. The first generation of the Test Kitchen tool was really awesome. You didn't need much config at all, but it also did stuff for you that I found a little surprising. It would install some things to help you. And they did help you until you needed to, let's say you had some code that absolutely needed an apt-get update. You're on a Debian system. The tool before did it for you. And so it's kind of hard to make sure that you actually did it if there's sort of a tool that does it for you. So I wanted to have my node to be as pristine as it possibly could be, so I know its state and I know exactly what's going to happen on it. I know the starting point, and I know what I did to it, so I can verify it with sort of nothing else going on. And if that means there's sort of extra code and config that you need to make that happen, I'm hoping that's forcing you as the designer of a library like a Chef Cookbook or a Puppet Manifest to really think about those dependencies and either choose to include stuff or exclude them and say, this isn't my responsibility, rather than the tool sort of by accident giving that for you. So we'll go through some of the concepts involved with Test Kitchen. Hopefully, I have a chance for a little bit of a demo, and then talk about sort of how Test Kitchen fits in with this sort of testing ecosystem, which is evolving still very, very quickly. So a little bit more terminology. So Test Kitchen runs what we call suites on target platforms, and we call those individual suite on a platform an instance. The way it does that is by using instance drivers or Test Kitchen drivers. So again, a platform, you could think of it as an operating system, a target platform. It could also be like the version of your operating system might be important as a platform. It may not be, but it may be like totally critical for patches, kernels, stuff like that. That might encompass the architecture you want to deploy on, any networking. If your virtualization is important, the act of deploying on a high compute EC2 instance, that might be important for your application. You might need to test specifically that versus a Vagrant VM, because maybe they have different performance characteristics. If that's important to you, you can think of a platform as a way to sort of model that. And then from the configuration point of view, it has a name that you give it. And that's rather, it's up to you what the name is. You as the author of that file kind of choose the name. So a suite, you could think of that as sort of a test suite in Test Kitchen today. That's basically a chef configuration. So it's essentially a run list. So I need you to run these recipes and then possibly some node configuration. So some node data that you may or may not need. Lots of projects end up being just series of run lists. But occasionally you need stuff like, I just need to set like a MySQL root password in this case so that I can like log into it later. I can have some tests that know the password, so I need to gem that in. And again, a suite has a name. Test Kitchen, by default, makes a suite called default. That's up to you whether you want to keep that or have it mean something more meaningful to you. And usually I would try and change that to, if I was testing a MySQL cookbook, I might have a suite for testing the MySQL client separate from the MySQL server. You end up getting the client libraries with the server, but you probably still, if you use both of those configurations somewhere in your infrastructure, it'd be great to test them isolated from each other. So those would be suites. That's sort of where you'd group that stuff. And an instance is really a combination. It's a pairwise combination of a suite and a platform. And that name just gets mashed together. You get your suite name and your platform name, and now you've got an instance name. And an instance has some actions you can run on it. So if you've used Cloud Tools or Vagrant, these sort of lifecycle things are sort of familiar. They might have slightly different names. So there's you can create one of these instances, converge it, which right now is basically running Chef or doing the configuration management bit, running your infrastructure code. Setup is installing a little bit of tooling to help you with any tests that you might want to run afterwards, and that's what the verify actions for, is to run any like test harnesses for your code to verify the state of that node, and then destroy, goes away. So a driver, a Test Kitchen driver, it's an implementation of all of those instance actions. So it's the bit of code that when you say, create this instance, it's up to the driver to figure out how to do that. That way, you can have, if you want to talk to EC2, you can use the fog Ruby gem and make the EC2 create server call. With Vagrant, you can shell out and say Vagrant up, stuff like that. Drivers are packaged as Ruby gems, which again means that you can use them from the community on the rubygems.org site. You can haul stuff in with a gem file. You can make an internal gem or even internal Git repo with the gem file. Never share it to the world, so you can make something either that can't be shared or something proprietary that's of no use to anybody. It's sort of up to you. It's just Ruby code you need to get into that running environment that if it looks like a gem, you can basically make it work. And each instance of Test Kitchen has its own driver associated with it, with its own configuration. So what this means is you could have 6 different instances, and you could say, like, this one, I'm testing Amazon Linux, so I actually need to run this with the Kitchen EC2 driver, but these other ones, I can just run them in Vagrant, except for this other guy that I need to run somewhere else. Or maybe the Linux ones, I'll run in like Docker containers because it's really fast. But the FreeBSD one, I'll do that with Vagrant. So you can come up with some probably pretty horrific looking kitchen config files, but it all kind of works together. So again, the drivers themselves, they're basically responsible for defining their own requirements for like, I need this credential or that credential, or you need to give me this username or stuff like that. And as a bonus tacked onto that really long statement, Test Kitchen can optionally run tests for you to verify the state of your node. So the idea with Test Kitchen is you can bring an instance into existence, run some code on it, and at that point you can turn around and inspect the state of it, so you can look at services running, packages installed, commands available, kind of whatever you want. The tests at that point are pretty divorced from the code that got it there. So it's not exactly a black box test because you're like right on the node, but you could sort of think about it that way, that there's some code that comes up into existence and can sort of look around and see what's going on, basically. So this is Busser is this tiny library that gets installed onto the node after Chef is finished running. And so I kind of like to think of it as sort of the Mars rover. for your conversion node. So it's basically shipping with the smallest set of tools it possibly can into a foreign land to go and discover and inspect and kind of peek around. Or put another way, it's a way to get like your tests in your way onto the converge node. And currently it's implemented as a Ruby gem. So right now, because Chef is implemented in Ruby, it's just discovering that, oh, I have a Ruby runtime here. I'm just going to use that. We end up hauling along Thor because it had a few nice goodies, but that's about it. It's just, it needs a Ruby 1.9 or above right now. So it's basically standard library. And it gets the node ready to accept sort of test suites. So there's these test runner plugins. Again, it's another sort of plugin architecture so that you can wire in your own flavor of tests. So far, these are the Ruby gems that are on the Ruby gems site. So you can write, the Busser Bash was the first one that I made to sort of spec out the idea. The idea is you can just write a shell script. And if it ever exits non-zero, your tests fail. And otherwise, success. So it's like a nice place to start if the idea of testing scares you. You can call it verification if you want. I endorse that. Just run a shell script, because most of us know how to do that. Because I suppose most of us verify all of this code right now by SSHing into a box and poking around. This is basically just encoding that and making it automatic. So, but if you don't have tests, that's okay too. Getting an exit of 0 from your CM tool is already far and away like gonna help. And when you're kind of from the perspective of a cookbook author, if you're in Chefland, I'm sometimes writing code that targets platforms that I don't use every day. And so I don't always know that the changes that I'm making or the changes that I'm pulling in are what the effect is going to be on the cookbook. So it's nice to have a way of having some of these tests. I can just run kitchen test and walk away and come back. And if everything's green, then I'm reasonably confident nothing's broken, which is probably better than what I was doing before, which is just hoping that contribution for an old version of CentOS probably worked. So I'm going to try a quick bit of a demo here. Okay. Is this too high for everybody? All right. Hopefully not. So basically what I'm going to do is I'm going to make the simplest chef cookbook I can possibly think of. So it'll just install Git. So it's a Git cookbook. Git cookbook. So really, to make a chef cookbook, hopefully there's not really anything too chef-like in this for anybody. But if you ever wonder what chef looks like, I'm going to make a cookbook here. So you need a metadata file, which is just metadata about the cookbook. Really, all that Test Kitchen cares about is that it has a name and it has a version, and that's enough. That's enough information for it to kind of make sense of the world. It's also nice if you have a recipe, and actually, you don't even really need to implement anything. We need to make an empty one. So there's a cookbook, done. So to install Test Kitchen currently, this is still a pre-release, so I believe it's in beta something or other. But it's been that way for a few months, and I've been holding off making a final release because I want the docs to be there. So stability-wise, I think it's reasonably okay. We can probably go forward with the release. I just want to make sure the docs are there. So you would need that pre-flag, or if you're using Bundler, then you can pull in the kind of normal way. So I already did that, and I'm scared about the Wi-Fi here, just in case. So I believe if I do kitchen version, so it is installed, I just pre-installed it. And I'm going to run this kitchen init, which is basically going to drop in just enough configuration for Test Kitchen to get going in this project. And really the most important thing is this .kitchen.yaml file. So if you've used Travis before, that should hopefully seem somewhat familiar. But we can take a look at it. Right now, this project initializer, it's actually a little dumb. It knew what driver that I asked for, but it's not smart enough to know what configuration to bring in. So you can see there's some configuration here that's assuming a vagrant, because that is sort of a default in the community. So I'm just actually going to get rid of these guys. Feel free to hack around in this file. This is sort of meant for you. So just because it says Ubuntu 10.04, maybe I don't care about that, and this is the only platform right now that I care about. Just keep it lean. So this first line is saying, yeah, I want to use the Docker driver for all the instances. There's a way that you can say, for this platform, I want to use something different or configure it differently. And there's just enough smarts now in this Docker gem that if you give it a platform name of Ubuntu-12.04, it knows what Docker base image to and tag to kind of pull off and get going. I don't know if Sean's pulled that in yet, but I hacked it out yesterday morning, and I just kind of built the gem and wired it in because it makes for better demos. So the kitchen list now shows you the list of instances. We've only got one. This is the default. All right. The default Ubuntu 12.04, it's just sort of auto-generated that name. It says that we're using the Docker driver, and using Chef Solo is sort of the default. So I can create this instance. And again, this is like way faster than would normally happen. I've got a lot of HTTP caching going on, and the Docker driver is actually pretty insanely fast. So don't expect startups always like that, but what it's doing under the hood is it's running some Docker commands to make sure the base image is there, put OpenSSH on there, so we've got like a way to communicate, and then kind of wire up the container. So if we list it, we can see it's created, and there is a login command, so it's similar to vagrant SSH. The driver just sets up a kitchen user, and kitchen is the password. So we've got our Ubuntu 12.04 container up, and you can see that we don't have Git on there because we haven't really run anything. So we got a clean box, and if I tell it to converge, this is the step that would see if Chef is there. If it's not, it would install Chef. It's also going to basically make a quick sandbox of like all of your code, any cookbooks that it depends on, like a Chef Solo configuration and stuff, wire all that together in a directory, shove it up to the instance, and then perform a Chef Solo run. And because we don't have any code in our recipe, it was really, really fast. So I'm going to write the most awesome one-liner ever. Assuming I spelt package right. I don't always spell it right. And that should hopefully give us Git. Thank God. OK. And it exits 0. So if I had made some weird typo, presumably we would kind of see an explosion. So if I was to, so the other thing I'm going to try and quickly do is wire in a test, and I'm not going to write it live. I'm just going to pull in one of these BATS tests. So it's basically a shell-based unit testing framework that's rather lightweight and kind of straightforward. So I'm basically doing the equivalent of looking for Git on the path. That might not be the best test, but it might be good enough, and that might be the way you're doing it by hand anyway. So we can just use that and run this verify action, and that will basically install that Buster gem on the remote node, see that we've got a BATS test, so it'll install the BATS runner, and then run our test suite. So that was the installing Buster stuff and then running a verify. So if we were to search for something like Git with 3 T's maybe. Again, these actions, you can just run them. So if you need to get your Chef code up to date, you can just kitchen converge and kitchen converge and kitchen converge. And when it flames out, as it sometimes does, it should not be exiting 0. If anybody finds that that's happening, that's totally a bug. I don't want a badly behaving tool that you would drop into CI. Exit codes are pretty important, I think, for CI tooling. So, and then finally, kitchen test. What that does is it rolls up all these actions into one. So it's going to run a destroy on the instance first if it happens to be there, then create it fresh again, converge it, set up the testing stuff, run any of the tests, and then assuming it's clean, it'll destroy itself again. And the idea being, if you have a cloud provider, oh yeah, see my three T's. So you can see it bombed out. Kitchen list shows the last thing it successfully ran was setup, so verified didn't work, but it's kept it in an open state. So it's basically crashed as soon as it possibly can. So if I caught my mistake, and it was in testing code, not production code, but I fixed it, then I can kind of continue on or run the test again, or just go like this and destroy it. If we wanted to look at the CentOS one, I don't think I'll have a chance to run it, but this is the other one that it understands. There is a way you can tell Docker for another distribution. I think like there's Arch, and Docker's got lots of base containers, so it makes that kind of testing pretty nice. So if we ran a kitchen test, you'll see there's 2 of them now. They have different names. So yeah, that's kind of a quick enough intro to Test Kitchen, I think. And how am I on time? Because I lost my little clock.
Yeah.
We pretty much at time?
Yeah, we need to wrap up soon or
okay.
get on to questions.
I will try this really quick. So, and I'll post the slides so you guys at least get sort of the snapshot view. These are sort of other tools out in some of the various communities. So there's linting is sort of looking for syntax problem style things in the chef community. There's Food Critic. In the Puppet community, there's Puppet Lint. For unit testing frameworks, these are what you can run in isolation on your workstation. It's not doing anything in the real world. They're really great for development because the feedback loop is really quick. It's also essentially a lie to me. You are kind of telling yourself a lie. So it's great up to a point, but then at a certain point you need to run it for real. So in the chef community, there's Chef Spec. Puppet community, there's RSpec Puppet. And what I would call integration is focused more on sort of like one server in isolation, sort of looking at it as a sort of full system. So that's kind of where I see Test Kitchen fitting into that, where it's focused more on one node. And frankly, if anybody has seen or knows of other ones, I'd be really interested to hear. I don't know if Test Kitchen is totally alone or if there must be other tooling around. So, and on the infrastructure side, I kind of view that as a little bit higher level, which is testing across clusters. This might be business value. So even Cucumber Suite Selenium could kind of fall into this. Cucumber Chef is a tool in the chef community. There's sort of a successor to that called Test Lab. The creator of Cucumber Chef has another. This was a bit of a spike that I worked on with Stephen. It uses Test Kitchen as a library to get instances up, and then uses Cucumber to sort of describe your problem around it. And my colleague Chris Roberts at Heavywater has Vagabond. If anybody's going to DevOpsDays Portland, he'll be doing a talk on that, so catch that if you can. And honorable mentions, handshakes are bad for visuals, right? Yeah, I'll make sure I put that in. We've got Berkshelf is sort of considered workflowy because there is integration with Vagrant. So it'll give you a Vagrant file. You can do Vagrant provisions and stuff. And Vagrant itself, I love Vagrant. So, and I am working on the docs and the guide for this. This is sort of an abbreviated version of that. So if you want to try this out on your own, I'm hoping in a week or so you'll be able to try it. And again, hopefully that gives you some confidence and happiness. And I think I'm at time.
Okay. Thanks, Fletcher. Do we have any questions? Okay. So we do a couple of questions, and then it's time for a break for some coffee.
Just quick and dirty. You point out one of the small submodules has a dependency on Ruby 1.9, which doesn't come by default in Ubuntu 10.
Yes. So right now I'm skirting around that because at least for Chef, it ships with a vendored Ruby, which is 1.9. So I know at least as far as that's concerned, that's what I'm getting right now. What I'm going to need to do when I start looking at can I bring in other tools is can I make those requirements any leaner, or is there a clever way that I can sort of fly one on that's not a system package, because I don't want to like pollute the node with packages and stuff if that's the thing you're testing. That was the problem when I got into this. I was testing for Ruby deployments with Ruby configuration management tool, and I was just like, it's insanity.
Any more questions? Okay, it looks like it's break time. Thanks, Fletcher.